Hello everyone and welcome to my very first video about hydrocarbons. Now I apologize for the bad speaker quality. I'm using some pretty crappy gaming headphones, but I promise that in future episodes I will find a better recording medium. So basically a hydrocarbon is an organic molecule with one or more carbons bonded to hydrogen. And this can form long chains of carbon-to-carbon bonds with hydrogen bonded to each carbon. Now in this drawing, I've drawn out all the individual atoms, but what chemists normally do is they just draw lines that show a carbon-to-carbon bond, and hydrogens aren't actually shown because since carbon can form 4 bonds in total, you can imply that all the bonds not shown are bonded with hydrogen. If they're bonded with anything else, they'd be shown. Now with hydrocarbons, there are 3 different bonds that the carbons can have to each other. They can have a single bond, a double bond, or a triple bond, and they each have special names. Ones with single bonds only throughout the entire molecule are called alkanes. If it has at least one double bond, it's an alkene, and if it has at least one triple bond, it's an alkyne. These molecules tend to have some similar properties. For one thing, they're nonpolar. This means they don't mix with water, but they will mix with other nonpolar solvents like toluene. They're very flammable because they have carbon and hydrogen, which are both very important for combustion reactions. But other than that, they're not very reactive because the carbon-to-carbon bonds and the carbon-to-hydrogen bonds are pretty strong. And these molecules also tend to be toxic to humans. This is why you don't drink gasoline. Gasoline's extremely toxic. They can also be carcinogenic. We'll get to that later. Despite the dangers, however, these molecules are super useful, especially for energy. We use them in cars, and we also use them in power plants sometimes. And we also make plastic out of them. And one final property is that hydrocarbons tend to be pretty volatile. This means that they evaporate pretty easily. They have very low freezing points. This is because nonpolar molecules are not very strongly attracted to each other. They're only attracted to each other by London forces, which hold nonpolar substances together, but aren't nearly as strong as some polar forces like hydrogen bonding. And this allows them to evaporate with less energy. Now, knowing how to name these molecules and what their names mean is very important for knowing what the molecules are and what they look like, what some of their properties are. The first part of the name tells you how many carbons are actually in the molecule. For instance, meth means there's 1 carbon. And if you're wondering, yes, this is where the word methamphetamine comes from. Methamphetamine has 1 methyl group attached to its tail, basically 1 carbon with 3 hydrogens. F means it has 2 carbons, prop means it has 3, but means it has 4, and so on and so forth. Some hydrocarbons can have more than 10, more than shown, but they're not super important for basic organic chemistry. And the second part of the word tells you the bonds that they have. We talked earlier about alkanes, alkenes, and alkynes, and the ending of the word will tell you which one it is. Now, if it ends with ane, like methane, ethane, propane, this means that there are only single bonds. If any double bonds exist, then the word's going to end with ene, like ethene, propene, butene. And if there are any triple bonds, it's going to end with ine. So ethyne, propyne, butyne, pentyne. And notice how there's no methene or methyne. This is just because there's only 1 carbon. So there's no way for it to double bond or triple bond with any other carbon. Now there is one more bit of information that you do have to add if it has 4 or more carbons, so butane, pentane, hexane, and so on and so forth. If it happens to be an alkene or an alkyne, then you have to make sure to mention where on the molecule that double or triple bond is. For instance, you can see here 1-butene. There is a double bond between the first and second carbon, and you want to pick the lowest number that you possibly can. So even if I were to flip this, you'd still call it 1-butene because you can count right to left or left to right. You just want to get the lowest number. Now, if the double bond was in the middle, we'd call it 2-butene just because it's attached to the second and third, but we go with the lowest number, so it's 2-butene. So it's relatively simple to name. You just have to make sure that if there's more than one, then you have to mention both numbers. So say I had hexene and there was a double bond between the first and the second and the third and the fourth, and I'd have to call it 1,3-hexene. Hydrocarbon chains can also form the backbone of other molecules, even polar ones. For instance, we have aldehydes, which consist of an oxygen double bonded to a carbon that's at the end of a chain, along with a hydrogen. We have alcohols, which are oxygen bonded to a carbon, and then oxygen is also bounded to a hydrogen, and that could be anywhere on the molecule, and it counts as an alcohol. And we also have carboxylic acids, which you can see in the diagram there. There's two oxygens, one's double bonded, one's single bonded, and one of them has a hydrogen attached to them. This group gives a molecule an acidic pH, and this particular group is very prevalent in organic molecules, especially ones that you find throughout the body. For instance, amino acids all have carboxylic acid groups, and also fatty acids, those all have a carboxylic acid group on the ends. For instance, stearic acid is a very long hydrocarbon chain with a carboxylic acid group on the end of it. The other two that I showed you are also very common. One example of an aldehyde is formaldehyde, which is very widely used for body preservation because it's very good at killing bacteria. Unfortunately, it's also carcinogenic, so it's not quite as widely used anymore, but it's still pretty common. And alcohols, well, obviously there's ethanol, which is the kind we drink. There's also lots of other kinds like methanol, which is wood alcohol, which is useful for other things, but is also super toxic in the body. So if you're trying to ingest any alcohol, just stick with regular old ethanol. There's a few other different compounds that hydrocarbons can form, and there's a ton of these, so I'm just showing a few. One is an ether, which is an oxygen with one or more carbons on each side. There's an amine, which has a nitrogen and two hydrogens attached to a carbon. And there's a ketone, which is almost identical to an aldehyde, but instead of an oxygen double bonded to the end of a chain, it's bonded somewhere in the middle. So they're very similar, but they're not quite the same. Now, as for uses, ether was another very old method of anesthesia that isn't really used anymore today because of potential dangers. Ketones, there's a bunch of different ketones that are used in the body, and acetone, the simplest ketone, is used in nail polish remover. And amines are super common in nature, and they're another component of amino acids which form the proteins in our bodies. There's another important reaction that hydrocarbons can go through, and this is called halogenation. And what happens in halogenation is that one of the hydrogens is replaced with a halogen, and halogens are fluorine, chlorine, bromine, and iodine. And these reactions can form a bunch of different molecules. One of them is fluoromethane, which is shown on the left, and trichloromethane, which is shown on the right. And that's also called chloroform, which you probably know used to be used as an anesthetic, but we don't use it anymore because of how dangerous it can be. It's carcinogenic and it's toxic. Nowadays we have much better anesthetics that probably won't give you cancer. Most of the hydrocarbons I've showed you so far were chains, but there's another very important class of hydrocarbons called aromatic compounds, and these are six-membered rings that are formed by six carbons, six hydrogens, and each have 3 single bonds and 3 double bonds. One ring is known as benzene, and there can be multiple rings. For instance, naphthalene is 2 rings attached to each other. And benzene is very prevalent, and it's the basis for a lot of different molecules that we use in the body. For instance, if you look at a model of serotonin, there's a benzene with a bunch of other stuff added on. And one reason is because benzene is very, very stable. It's not going to break apart very easily. So if you need a molecule that you can work with a bunch, but you can easily rebuild, benzene is great because it'll hold its shape no matter, through most of the chemical reactions that you put it through. That's going to do it for this video. I know there's a lot of other stuff I could talk about in organic chemistry, but I'll have to save that for another time. Thank you all so much for watching my very first YouTube video. Consider subscribing for more future content. I would really appreciate it. And I also do have a Patreon link in the description. That's completely optional. I'm not going to pressure you all to contribute money to a YouTuber who literally just started and made everything in Microsoft Paint. So anyway, thanks for watching, and I'll see you next time.